Okay, so y'all remember what these data we're looking at? We were trying to test a math skills intervention and a confidence building skills intervention to see how they affected fear of stats, confidence in stats, depression over stats, and stats exam scores, right? Helps to kind of keep in mind, like, what are we actually doing with this data set? So the same data set we've been using, you need to download the fresh version. Do not keep using one that has been saved multiple times on your computer, because you might have accidentally changed a single data point, which could mess up all of this. So download the fresh data set. Go ahead and download the SPSS lab3 document. Tells you the instructions. Strongly encourage you to do this in a computer lab. You will have to be on a UA network. Download this. I would go ahead and be writing your name and CWID. I would be saving as many times as possible, preferably to a cloud, right? So you don't lose this to the box or OneDrive or something. Okay, so we are going to do one sample t-test, dependent samples t-test, and independent samples t-test in this lab. This lab is less involved as far as the SPSS functions go than lab 2 was, but it is more involved in interpretation. So here, interpretation is the harder piece, where in lab 2, it was really just doing all the little things with SPSS. So hopefully this will actually take you less time in the computer lab, but the interpretation piece will be very important, and it is also what is most featured on the exam for those 4 items. So first, we're going to do a one sample t-test to determine how each group's fear of stats at time 1 compares to the t-distribution of all college students' fear of statistics in general. Remember your goal with your one sample t-test, you're collecting data from a single sample. You're comparing that known sample mean to a population fear of students in general with a known mean unknown variance. So we're effectively doing 2 one sample t-tests here, because we're going to split our data set. We're going to have data separately for the math skills group and the confidence building group. We're going to look at their fear of stats at time 1 and see, is that the same or different from the population of students' fear of statistics in general. We're assuming the population of fear of statistics in general value is 39. It's 39. So we know this population mean of 39. That's the reason one sample t-tests are not used often in the real world. It's very rare that we actually have a known population mean, okay? Remember, I mess with these data sets and make them to where y'all can use them, and I just said, just assume it's 39, that's our known population mean for this example. So because we're interested in looking at single groups separately, we need to first split our file, which y'all have done now several times, but we're going to split our file by group. That way we can do one analysis and it will show us output for the groups separately, okay? So the first thing we do is split the file. I go to data, split file, organize output by groups. Our grouping variable is group or type of class. Remember, there's variable name, variable label, group, type of class, synonymous here for the same variable. That's our grouping variable. Now, all of our output is going to show output for math skills group and confidence building groups separately. And click OK. Doesn't do anything, doesn't show you anything, but you should see your output separated by group now. That was all of this. All of the instructions for t-tests are in the textbook. If I remember correctly, they were fairly straightforward. I'm just going to show you. It's all in the same part of SPSS. It does involve a ton of menu clicking, so that's nice. You can analyze, compare means. Here you can see one sample t-test, independent samples t-test, and paired samples or dependent samples t-test. So all of these t-tests are in the same menu functions right here, okay? Compare means. So we're doing a one sample t-test to start. Our variable of interest is groups fear of statistics at time 1. Fear of statistics at time 1. So that's the value we pull over to our test variable. We're comparing comparing each of these groups separately, their means, to this population with a known mean. A known mean goes in test value, okay? I've written use test value equal 39. That is our population's known mean fear of statistics score, 39. I don't ask you to do effect sizes. One nice thing about t-test is that it's gonna give you mean and standard deviation. You don't even have to click through extra menus. So that's all you had to do, and you've actually just now, with this button, done 2 one sample t-tests, separate for math skills group and confidence building group. So it's these tables, one sample test, that you copy and paste and put in your file. I like it when y'all do copy as image. It's the easiest thing to do. Paste. You can see it says to do one sample test tables, which would be 2 tables total. I actually put copy as image. I got a lot of emails that are like, will you accept me taking a picture with my phone of the computer lab computer? It's fine. Whatever you do to get that image in your homework where Josh and Danny can just read it, okay, enough, is fine, okay? That's fine. So I've been copy as image and paste, and you'll do that for both of your one sample tests. So this particular one sample t-test is comparing the math skills group fear of stats time 1 that has a mean of 39.4 and a standard deviation of 4.76 to the population of stat students in general's fear of statistics at time 1, which is 39, that known mean that you were provided, okay? So one sample t-test is comparing our single sample with our mean and standard deviation to a population with a known mean but unknown variance standard deviation, okay? So it definitely helps to know what you're doing. So this is for the math skills group. Same thing here, but this is for the confidence building group. So you run 2 one sample t-tests. That's item 1. You go to question 2, which can be done later once you have these data. It would be easiest to go ahead and do it now. I mean, it would be easiest to go ahead and do it all at once because you'll be missing means and standard deviations. So you're asked to report means and standard deviations, okay? So if you're in the computer lab and you're in a hurry, you might want to go ahead and just pull all the tables and then delete extra later. But you are asked to report sample means and standard deviations all the way throughout, okay? So it tells you tips, like report this. Here, there are example reporting formats in the textbook. I actually think it's easiest if you go back and look at our slides. I gave y'all an APA style report, multiple examples for each kind of t-test in the slides, okay? So, and I tried to give y'all hints here too. Include which group. Here, the math skills group are all college students reporting greater fear of stats. Make sure to report both groups' means and the math skills group standard deviation in your answer. Hint, the math skills class mean is in your output, while the population mean was assumed to be 39, okay? So we have our sample mean in our output. Our population mean was assumed to be 39, so this value, what this one sample t-test is doing is saying, is 39.44 from our sample, is that mean statistically significantly different from the known population mean of 39? We don't know if a small mean difference like that is statistically significant or not unless we actually do the inferential test statistics, which will factor in standard error. Can y'all tell me, is that statistically significant or not? This is our two-tailed p-value, 0.718. Is there a statistically significant difference between math skills group fear of stats and the population group, population fear of stats? Is there a statistically significant difference between that 39.44 and 39? P is greater than 0.05. Is that statistically significant or not? There is not a statistically significant difference, okay? So remember, P less than 0.05, your alpha here, is statistically significant. There is a statistically significant difference, okay? If P is greater than 0.05, there is not. So you have to be able to interpret this. So you have a t-value, you have degrees of freedom, which you have to use in reporting. You're gonna always want to report the two-tailed p-value. You can also just write p greater than 0.05, I've accepted both. You're also gonna have to report your group mean and standard deviation. So that's the information you'll need once you're asked to do this, and you have to do, analyze each one sample t-test separately, okay? So, I recommend, as far as formatting goes, to go to the examples on the slides. This is one sample t-test. Okay, one sample t-test reporting. So, I've really only asked you for the second sentence here. You can do both of these answers in one sentence each. Here in the example, it says the test revealed college students who participated in our PEPI therapy, our sample mean, our sample standard deviation, reported better mood than college students in general with a known mean of here 5. Okay, you can pull that information. Your known mean though is 39. That was the value that was provided to you, right? Then you can report your t-test statistics in APA style. You have lowercase italicized t. What is this value in the parentheses? Degrees of freedom, equal your t-value, comma, you have your italicized p. You can put less than or greater than 0.05. You can also put equal in your actual p-value, comma, two-tailed. You need to use two-tailed all the way throughout. So going back to our assignment here, you're looking at math skills, fear of statistics at time 1 compared to college students in general fear of statistics. You could basically report something to the effect of the math skills class reported a similar fear of statistics at time 1, report those mean and standard deviation, as the population of college students who had a known mean of 39, and then you report those t-test statistics. Okay. So our group mean and standard deviation, t-test statistics. I have a question on that. The SPSS part is easier, but the interpretation part is harder. Okay. So this is the next one sample t-test. This is the one comparing confidence building classes, fear of statistics at time 1, to college students' fear of stats in general, okay? And again, I tried to give you lots of hints, make sure you report group mean and standard deviation. The population mean was assumed to be 39 above. That information was really right here, test value equals 39. Basically, this one is asking, is our sample mean of 40.63 statistically significantly different than the known population mean of 39? Is there a statistically significant difference? Yes or no? He says yes. He says no. The few people who were brave enough to answer are correct. Not a statistically significant difference here between our group confidence building groups, fear of stats time 1, and stat students in general, fear of stats. I have written answers in one sentence, but you are allowed to do 2. It does have to be complete sentences. Do I have any questions about the one sample t-test? To me, those are some of the that one is kind of the hardest to kind of like mentally grapple with. Yes?
Can you repeat the layout of like what you wanted, how you wanted us to write our answer?
Yes, I'll do it for the confidence building class. So here's the confidence building class. You could say something to the effect of the confidence building class's fear of statistics. The confidence building class reported similar fear of statistics at time 1, reported their mean and standard deviation. You do that in parentheses, italicized M equal, comma, italicized SD equal, right, parentheses, okay? As the population of college students who had a known mean of 39, comma, and then do your t-test statistics, like you see right here. But do you see how I have the mean and standard deviation in parentheses? M is italicized, SD is italicized, P is italicized, P is italicized. That's all part of APA style. This is reporting a statistically significant difference in the groups. So if you're not, you would say they reported similar amounts of fear of statistics, P greater than 0.05. So make sure you know how to like interpret and understand a p-value. And again, the p-value y'all are gonna need is this, for some reason, SPSS latest version changed it from saying two-tailed to two-sided. Okay, so this value. So you can put P equal 0.268 for this one, or P greater than 0.05. I've had it notes that I will accept either, the TAs will accept either. Any other questions about the one sample t-test? One sample t-test are comparing a known sample mean to a population with a known mean but unknown variance. You have to know that population mean, and that's the value you plug in as the test value. Okay. To me, the other two kinds of t-tests inherently make a little more sense, and they are substantially more likely to be used in real life. So, again, we're doing one thing in SPSS that's gonna spit us out two separate analyses. This time we're doing dependent samples t-test for each group's fear of stats at time 1 compared to their fear of stats at time 3. We're gonna keep our groups split, so we'll see within subjects, within each group, how does their time 1 fear of statistics change from time 1 to time 3. Basically did our intervention work. So we had this kind of pre-intervention fear of statistics at time 1. We did this intervention, the math skills group got the math skills intervention, the confidence building group got the confidence building intervention. We tested them again at time 2, and then we tested them again at time 3 a few months later, right? So this is comparing time 1 versus time 3. Did our interventions work? Okay. So you keep your file split. Keep your file split. And then again, the instructions are in the textbook. I'm gonna show you right here. And you're gonna copy and paste only this paired samples test table. So analyze, compare means. Remember, SPSS calls this a paired samples t-test. When you're doing something with time 1, time 3, should you do time 1 minus time 3, before minus after, or after minus before? You all calculate different scores for dependent samples t-test, after minus before, or before minus after? After minus before. So that logic holds. So we're going to put time 3 fear of statistics in first. Then time 1 fear of statistics. We don't have to go through all these menu options. I didn't ask for effect sizes. Because we still have split groups, you have just now done 2 separate dependent samples t-tests within each group. This one is comparing the math skills group, fear of statistics at time 1 and time 3. This one is comparing the confidence building groups, fear of statistics at time 1 versus time 3. This will also give you an entire extra table that you need to ignore. You need to ignore this paired samples correlations table. This is not your t-value, that is an R value. This is not the p-value that you are going to be reporting, okay? Again, this is not the information you need in this paired samples correlations table. You'll need information from this table to get your mean and standard deviations, and this is the table you actually need to copy and paste over into your file. Yes?
Did you say we didn't need the estimate of effect sizes?
You don't have
Estimated.
effect sizes. You can uncheck that box. If you keep it checked, it's gonna give you more numbers to grapple with, so I would honestly just uncheck it, but it's not gonna hurt your grade either way. So this is, again, 2 dependent samples t-tests. So, this is the table that you'll copy and paste as. So copy as image, right? And then you'll paste it here. It says, copy and paste both group paired samples test, 2 tables total, okay? If you basically plan to do this in the SPSS, if you do this in the computer lab, or only trying to kind of just quickly do the SPSS part, you are still gonna need this information, okay? So just keep that in mind, you're still gonna need this information, because you're gonna have to report mean and standard deviation. You'll do your 2 tables here that are required, and then you're gonna interpret this. So first, you're gonna report the results of the dependent samples t-test that's comparing the math skills groups, fear of stats at time 1 and time 3. Use this reporting format. It's also in, I don't think mine is any different than the textbooks. Mine might be a little bit easier to digest. Something that I consistently forgot to add was that. So here's a way to report a dependent samples t-test. So in this example, it says a social psychologist measured couples' communication quality before and after marriage. We walked through that example in class. You don't even have to include an introductory sentence in your answers. You're jumping right to the answer, okay? It says the study found a significant decline in communication quality, dropping from a mean of SD before marriage to a mean of SD after marriage, comma, and then you report your t-test statistics. For y'all, here, the math skills group, it could say something, well, let's first ask. Okay. Fear of stats at time 1, 39.44. Fear of stats at time 3, 36.69. There is a mean difference here of negative, it's 2.75. The group means differ by 2.75 here. Can you assume that is statistically significant? You can't assume it, but it is statistically significant if you look at this table, okay? You can't just see means and say, yep, there's a difference, there's a statistically significant difference. However, because we actually ran this dependent samples t-test, we actually see, yes, there is a statistically significant difference. Here, P is less than 0.001. P is less than 0.001. Two-tailed, the value to pull in. So I could write this up, this is the math skills class, by saying the math skills class's fear of statistics decreased from time 1, report that mean and standard deviation, to time 3, report that mean and standard deviation in parentheses, and then comma, report my t-test statistics. So my lowercase italicized t, degrees of freedom, in parentheses, equal my t-value, negative 4.676 here, comma, italicized p, less than 0.001, comma, two-tailed. Because we did after minus before, it's gonna show you after and before, time 3, time 1, and there's order in this little table. Make sure you report these correctly. So if you wanna say, you know, it's had less fear of statistics at time 3 relative to time 1, that's fine. If you wanna say there was a decrease from time 1 to time 3, that's fine. Make sure you're reporting the correct mean and standard deviation. Don't get those flipped. Don't just assume that row 1 is time 1. It's not. Yes?
Is the mean for both of these mu? Like, is that similar?
Is the mean for both of these mu?
Yeah.
These are actually both sample mean M. So that's a good question. One sample t-test includes population mean mu. Once you get to dependent samples t-test, you're no longer talking about populations. You're working with a single sample for which you have data collected at 2 time points. Sample mean and standard deviation time 1, sample mean and standard deviation time 2. So it's M and SD. That's a good question. Do I have any other questions about this dependent samples t-test? Is this helping shed a little bit of light on like the point of these t-tests, like what their goals are? I hope, maybe. It's also nice to know that you don't have to do all these insane calculations, right? You can just plug it into SPSS and it's like, wow, I didn't even calculate S squared. Yes.
When you say the two tables, do you mean the two bottom tables?
The two tables that you're asked for
Yeah.
are paired samples test here, paired samples test here.
Okay.
Paired samples test tables, two tables total. This is one of the assignments where it really just pays to read every single little word, don't miss any little detail. Any other questions about dependent samples to test? Okay. So again, in one sample t-test, you effectively ran two t-tests because you had split file, but you only had to plug it in once and it showed you the two separate ones for each group separately. And then you reported the results of one, you reported the results of the other. Same thing went down for dependent samples t-test. You effectively ran two of them. You had your file split, so you had one dependent samples t-test for this, math skills, one for confidence building. You report math skills group, confidence building group. Make sure you're looking at this, because if you start reporting the math skills data and the confidence building question, that will all be incorrect, right? Once we get to t-tests for independent means, independent samples t-tests, you have to unsplit your file. So, to me, if you missed the class before spring break, we introduced independent samples t-test, and I was saying that, again, to me, this one is the one that makes the most sense, just like intuitively. This is the kind of t-test where you have two groups, you compare them on a single score. So for example, if you're trying to test some effectiveness of some anxiety drug, you get an experimental group take the real drug, a control group take the placebo, compare their anxiety scores at the end. That would be an independent samples t-test, right? So you have two separate samples that you have collected data from with sample M and sample standard deviation. You're comparing that, the two groups, on a single score in an independent samples t-test. So here, we're doing an independent samples t-test to determine if our two groups differed, okay, in their fear of statistics at time 3. So determine how the math skills class's fear of statistics at time 3 compares to the confidence building class's fear of statistics at time 3. We've measured fear of statistics at time 3 in our groups separately, and we're comparing them. You have to unsplit your file, because right now, SPSS is considering those groups entirely separately and won't let you put them in the same analysis, okay? So the first thing you have to do is unsplit your file. You go to data, you go to split file. You can click just analyze all cases. It always makes me feel just a little bit better to actually move this out and then click analyze all cases. Either way, as long as analyze all cases, do not create groups is clicked, you're good to go. Independent samples t-test is not going to work if your file stays split. Click OK, nothing really happens, but you'll see it later in your output. So, we are first looking at independent samples t-test to compare groups fear of stats at time 3. We're going to analyze, compare means, independent samples t-test. Our variable of interest in this first one is fear of stats at time 3. Fear of stats time 3. What do y'all reckon our grouping variable is? Group, right? It's kind of confusing. The grouping variable is group, okay? We're trying to compare our two groups, fear of statistics at time 3. So for grouping variable, you put in group. The odd thing about this is you have to define the groups, okay? You're just going to use the defaults here. So 1 and 2 are going to just be plugged in for group 1, group 2. You already have these groups labeled in your data set that was provided to you. So the output is not going to just say 1 and 2, it's actually going to make sense. But for some reason, in SPSS, they want you to define your groups. Just do 1 and 2. But continue. You can uncheck estimate effect sizes. Click OK. This is what you need to copy and paste over. It's not gonna fit in your Word doc, it's gonna be too wide, that's why I say copy, paste, image. Yes,
How did you get the group to go into grouping variable?
analyze, compare means, independent samples, t-test. You just pull group over, the variable group, the grouping variable with the arrow. Did you do that? And then define groups. 1 and 2 default is fine, click continue, and then you should be good to go. If you don't define your groups, it's gonna give you an error message. Okay. Make sure you only see that one. Okay. Here's our table that you're copying and pasting over. Again, it will be too wide. The tricky part of this output is it's actually showing you something that brings me back to graduate school, this Levine's test, okay? So you won't have to worry about Levine's test. If you go to graduate school, you will learn about what Levine's test is doing. This is an F value for an ANOVA, and this is a P value. This is not the information that you need. Like, don't even look at it. This is not, again, this is not the information that you need. This is not your P value. If you report that, it will be incorrect. It's also going to show you these two rows. Equal variance is assumed, equal variance is not assumed. We are going to assume equal variances. In this case, we actually should, based off of that Levine's test, okay? We are going to assume equal variances. The information that you need is this right here. Literally only this. This value, this value, this value, this value, this value, this value. Okay? So here, this test is essentially comparing the groups fear of stats times 3. So the math skills group mean was 36.69. The confidence building group's mean was 34.44 on their fear of stats at time 3. Well, is that a statistically significant difference? Here, that's a difference of 2.25 points. I can see that right here. If I subtracted these, it would be 2.25 points. Is that statistically significantly different once you factor in the spreads of the distributions, the standard error? Here's our p-value, 0.302. So is this a statistically significant mean difference between groups or not? It is not. The groups reported similar levels of fear of statistics at time 3. So once you get down to item 7, here, this is where you're reporting this first t-test comparing groups fear of stats at time 3. You could answer with something to the effect of the math skills class report M and SC in parentheses, and confidence building class report M and SC in parentheses, reported similar fear of statistics at time 3, comma, report your t-test statistics. So lowercase italicized t, degrees of freedom in independent samples t-test is now degrees of freedom total. That's why that's 30. So it's 16 minus 115 plus 16 minus 115. Degrees of freedom total. This is the value that goes in parentheses. Equal, here's our t-score, 1.05, comma, p equal 0.302, comma, two-tailed. I also, again, have it to where you can just write p greater than 0.05, two-tailed. This was not a statistically significant difference between groups fear of stats, p greater than 0.05. Now I actually have you run another independent samples t-test on a different variable of interest. So now we're interested in comparing the same group's stats exam scores. Stats exam scores. Did one of these interventions actually work to improve a stats exam scores better than the other? We go to analyze, compare means again, independent samples t-test. Our variable of interest has changed to stats exam. Everything else is the same. Technically, if you put 2 variables in here, it's going to show you your 2 independent samples t-tests that you were asked to run, okay, separately. I want you to do it one at a time, just so you don't confuse more rows and more columns, okay? So we're just looking at stats exam here. Grouping variable remain the same. If for some reason you got kicked out of SPSS, you came back in, you would have to define your groups again. Click OK. Here's your independent samples t-test comparing group stats exam scores. The confidence building had an average of 80.25 on the stats exam. The math skills class had an average of 66.63 on the exam. That seems like a pretty big difference in exam scores. However, you can never assume that is statistically significant until you actually run the inferential test statistics and look at your p-value, less than 0.001 here. So does that mean different, statistically significant or not? Yes. Which group did better on the stats exam? Significantly better on the stats exam? The confidence building group, yes. So the confidence building class, parentheses, M equal, comma, SB equal, in parentheses, perform better than the math skills class, mean and standard deviation again, on the stats exam, comma, report your t-test statistics. Lowercase italicized t, parentheses, degrees of freedom, equal your t-value, comma, p, less than 0.001 here, comma, two-tailed. So it's important to note in some of these analyses we found no difference. In some of them we did find statistically significant differences. You have to be able to interpret that, both in SPSS Lab 3 and on the exam. Okay, and on the exam, the 4 items are multiple choice, but the differences in some items are very, very small. One might say degrees of freedom equal 15, one might say, the other option might say 14. One might say P less than 0.05, the other one might look very similar but say P greater than 0.05. You have to really pay attention to the details on those 4 exam items and in this lab. That's the 2 independent samples t-test. So you actually run the 2 separate ones, 1, 2, and then you analyze them, 1, 2. And that's lab 3. Have any questions about the independent samples t-test? Does that test make the most sense to everybody? Not just me. I like the idea of comparing groups. A lot of the times that's what we're doing in real life. Comparing 2 group means. Any questions on SPSS Lab 3? Again, I recommend doing it in one sitting. In a computer lab, you're gonna have to be in a UA network. No questions? No questions? Okay. So, since that's just a lot of, that was a lot of numbers and detail, we're not gonna do the independent samples t-test calculations that we're talking about doing today. And instead, we're going to look over